Yep, sounds good.
So thanks everyone for joining us today. This is actually our second session. I don't know if anyone or if everyone was able to join us earlier. We had a special guest appearance from my dog there unexpectedly, which always, is a fun time. But this time we're going to look at running GitHub workloads on VMware, and we've been working closely with VMware recently. I'm actually going to let Jeremy do a quick intro. Is that okay, Jeremy? And maybe talk about our partnership.
Sure thing, Steve. Yeah. So, hey, everybody, Jeremy Adams. I was on the last session as well, helping out with some of the questions, and I'll do the same sort of thing today. But just to set a little bit of context, I work on the Business Development Alliances team over at GitHub and on a number of strategic partnerships, for example, with VMware. And so we're really excited to work with the VMware team as well as the Azure team and the VMware Cloud and AWS teams to do a validation recently of our Github Enterprise server product, which is typically an on-prem product, so heavily used by our customers in VMware vSphere environments. But it's really interesting to see this trend towards hybrid cloud, and so we wanted to make sure that we validated it not just on on-prem vSphere, but also on the hybrid Azure VMware solution that was just announced by the Azure team, as well as VMware Cloud on AWS that's been around for a while. So we've just done that validation, and this talk, a lot of this talk comes out of that work, and so we're really happy to share that with you. I'll turn that over to Steve.
Cool. Thanks, Jeremy. Yeah, so the title of this session, GitHub Enterprise Server and GitHub Actions on VMware everywhere. So hopefully that will be a lot clearer by the end of the next 30 minutes. We've got quite a lot to get through. So let's jump in. A session, which was, I think, an hour ago, we gave a quick overview of GitHub Actions, provided a couple of kind of CI/CD codes and supporting workflows, all enabled by Actions on GitHub.com. In this session, we're going to focus on the enterprise and take a look at how you can kind of execute and operate very similar scenarios, but in your own data center or private cloud enabled by VMware. So GitHub Enterprise, in case you're not aware, this is our enterprise product. It's available in a couple of flavors: Enterprise Server and Enterprise Cloud. With Enterprise Server, you host it on your own in your own data center or private cloud behind your firewall, and it provides a lot of the enterprise features that our customers love, like SAML single sign-on, access provisioning, lots of additional advanced security features and priority support as well. And you can find out more at github.com/enterprise. And today we're going to take a very exciting sneak peek at actually some very new features that are available on GitHub Enterprise Server, currently as a limited private beta. So if you're interested in trying this stuff out for yourself, and we'll be sharing this link a few times, don't worry, you can sign up at resources.github.com/beta sign up, and that will get you in to these new exciting beta features for GitHub Enterprise Server that you can then run on your VMware hardware. Cool. So I said we don't have a ton of time. It's only half an hour. So we are going to actually literally just dive right in here straight into a demo and hopefully make the most of our time together. So let's get going. So the first thing we need to do is install GitHub Enterprise Server on VMware. We have pretty good docs for this on docs.github.com that walk you through the installation. We're going to run through it here as well. And there are a number of prerequisites that need to be met. You actually need a license to install GitHub Enterprise Server, although you can get a trial. And you need, obviously, your vSphere hypervisor and vSphere client as well. There are some hardware considerations depending on kind of what you're predicting you need to handle in terms of kind of developer or software-based workloads. So we'll reference this a lot in the demo as well to make sure we're kind of sizing everything correctly. Our releases are public and published here on a pretty regular cadence. I think every like 6 weeks we publish a new version. Today we're going to be using 2.22.0, which was recently released, and this is the one that has all of those cool and exciting beta features. So we'll go ahead and take advantage of this and download it, which you can do here. So we're going to be running on VMware, so we need to select the kind of OVA template to download. And actually, this is a pretty hefty template, so we're not going to download it here. And instead, here is one that we prepared earlier, Jeremy and I. So in our vSphere client, if we jump over to our content library, here is our OVA template that we uploaded, just so we don't have to wait around, hang around for that to upload. And so we see our template for GitHub Enterprise 2.22.0. And to speed things up a bit, let's just generate a new VM from this template already. So let's give this thing a name. And I actually don't recommend including the release in the name because that's going to change when you upgrade it. So we just call it GitHub Enterprise Server. We'll choose like an appropriate kind of logical home for it in our workloads folder and a compute resource. And let's choose a home for our storage for like configuration and disk files, the network configuration, make that selection there. And then we'll come back and edit the hardware configuration for our needs shortly based on the docs, but let's just save this first. And then over in our workloads folder, we should see our new VM, GitHub Enterprise Server, and of course we need to edit the hardware configuration. So let's go in and edit those settings. And we need to kind of jump back and forth a little bit between the GitHub docs at docs.github.com and our vSphere client. So there are basically two tables here that correlate your hardware requirements against the expected load. And the expected load you can calculate based on kind of number of users that will be using this, and for the beta features, the sort of number of workflow executions per minute that you expect. So in our scenario, we'll assume that we want to support 3,000 developers, and let's say we expect them to execute on average maybe 25 workflows per minute. So based on those assumptions or predictions, we can configure our hardware appropriately. So it looks like we'll need like 61 gigs of memory, 8 vCPUs, and a bunch of storage, root storage and attached storage for our instance. So let's go ahead and set that up. Let's apply that config over here. So CPU should actually be 8, not 4. Memory for 25 jobs per minute is going to be 61 gigs. So let's go ahead and beef that up a little bit to 61. Root storage, there's a bit of a rounding error there, but I'll live with it. We should have 200 gigs there, and I'll attach another disk for our attached storage, which will be 300 gigs. So this will be like where our, if you're using GitHub, like our repo data will live, and if you're using things like Git LFS, that's where those large files will live as well in that attached storage. Let's just do a quick check and make sure that this is configured correctly for our needs. So the 3,000 developers running, we predict 25 jobs per minute. This looks, I think, pretty good to me. So let's go ahead and apply that. And with that applied, we can actually power this on. I just need a quick. Let's power this VM on, and we can see it in the web console here and sort of see the magic happen as this thing comes alive. We can see in in the logs, we need to actually navigate to a web browser to complete the configuration in what we call our management console. And we see the IP address there, 192.168.165/setup to do that. So let's go ahead and open that up. And it just so happens that I have another VM running that will allow us to connect to our enterprise server instance. This is just running like a vanilla Ubuntu server instance. And we can access our GHES instance, our GitHub Enterprise Server instance from that VM. So in our Ubuntu server, I'll navigate to the web console. So this is 192.168.165. 1.65/setup. Right now, by default, when it powers up, we have like a self-signed TLS certificate, so we have to kind of accept that security kind of warning. Actually, we have to do it twice because the management console is actually running on a dedicated port, 8443. So that's fine. I'm going to accept those. And then we see this wonderful installation page with a couple of things that we need to add. So we need to provide a license file. It just so happens I have one here that I uploaded earlier. And for this management console, we need to password protect it because we don't want anyone kind of accessing this. So let's choose a nice and secure password here. And we can then continue with the configuration and sort of finish this installation. There are a number of options for an installation. You can just set it up from scratch as a new install, which is what we'll do. You can also kind of restore from a backup or set up a replica in a high availability configuration. There's a lot of settings here, right? And the first thing I need to do is just add my SSH key so I can connect to the server over an SSH session, which is actually pretty fundamental for operating this thing. So I'll just add the public SSH key from this Ubuntu server that I'm currently on, and that'll let me access the server over SSH and run some additional admin commands. I always forget to hit that add key button, but yeah, that's added now. There's a few other things in here that we really should configure, especially for production workloads. I'm going to move past all of these options just in the interest of time. I do recommend kind of checking our docs, setting this stuff up all correctly, running the server in kind of high availability mode, and definitely install a valid TLS or SSL cert. It may make your life a whole lot easier. There are options in here for like monitoring and rate limiting, all of that good stuff. But for now, we're just going to move on ahead with the defaults and wait for our configuration to be applied here, which shouldn't hopefully take too long. All right, sweet. So that's applied, and now we can actually visit our instance. The first thing we need to do is create a user. So there are different options for logging into GHES. You can connect it up to an LDAP, or you can use SAML, or you can just create usernames and passwords directly on the instance. Because we're pretty stretched for time here, this is what we're going to do. So I'm just going to set up a new user who will be our first admin account. I'll take the kind of coveted Octocat user. Because this is a brand new instance separate from github.com, you can come up with whatever lovely usernames haven't been taken. And there's only one user on this instance, so I'm going to be the Octocat. And I will set up an organization as well that's going to be helpful for our demo. So I'll just use the organization name. I'll just use Octo, which is separate from our office of the CTO. Absolutely nothing to do with that at all. And let's skip the rest of those steps so we can get on with the demo. So here I am now with our brand new sparkling Octo org on our new GHES instance running on VMware. And to continue with the setup, to enable those exciting beta features that we announced, I need to jump over to this kind of private administration area that only admins can access. So Octocat as an admin. And let's jump into some of our enterprise policies. So you can configure things in here like the default permission sets and such. But the main thing I want to do here is enable our feature GitHub Connect, which, as it says here, allows you to share specific features and workflows on GitHub Enterprise server and github.com. And this will allow us to actually consume any of the public actions that are on github.com built by the community that we saw in our earlier session today. So this is really useful. It really allows you to kind of bring the power of the community to your on-prem environment. So let's definitely go ahead and enable this. And if you're not comfortable doing that, you can place limitations around this and either block it entirely or allow certain organizations if you want. But I'm going to just allow everything because I'm feeling very generous. Cool. So I've connected my enterprise org here, and let's now jump over to enabling this. So here's our warning here. So a lot of what we're showing is currently in private beta. So if there's stuff that you can't do unless you're in the beta, I'm going to throw up this page, and please visit this URL, resources.github.com/beta sign up to get your hands on with this. But we're going to show you nearly everything and as much as our product team will allow us to do. Okay, cool. So let's with that said, let's jump into the rest of this. Okay, so actually I need to here jump over to a terminal. So I added my SSH key earlier, and that's because to complete this, I need to do it from the command line. So let's do this. And I'm going to SSH onto my, my instance here, and I can just say SSH GHES, because I did it as a config in my SSH config. And some of the steps here are hard to memorize, so it just so happens I have a very handy gist, so I can just follow along and copy and paste. So let's go and look at that gist. And there are a bunch of commands we're going to run here, but we're not going to show you the precise details because, as I said, this is currently in a private beta. But essentially what we're going to do is configure blob storage, which is required for this sort of ephemeral output from GitHub Actions. So think about kind of logs and artifacts. We'll use an S3 bucket here, but you could equally use the Azure equivalent, or we also provide min.io, which I think is like an abstraction for S3. And then we're going to run a few other kind of pre-checks, health checks, and apply the config. So that stuff is a bit hidden at the moment. But those are the steps that we've kind of run behind the scenes here. And at the end of this, the last step we need to do is just apply our config on the instance. This is a little command line utility that is the same thing as reloading that management console that we saw earlier. So it's going to update our storage, restart our services, and make sure everything is healthy before making the application online again. Okay, cool. So we did that kind of awkward beta enablement stuff. And as I said, please join or please sign up for the beta if you want to do that yourself. And now, essentially, after reloading this, we have a new policy here for actions. So actions is enabled for all organizations on our instance by default. And now to kind of complete this setup, we just need to add a runner that will actually run our workflows for us. In future releases of actions on GHES, you'll be able to use the github.com hosted runners if you want, but for now, it's necessary to host your own. So let's walk through this process quickly. This will create a runner at kind of the enterprise level, so it will be made available to all of the organizations on the enterprise. I'm just going to add a new runner here. I'll stick with Linux and x64 architecture for this runner, and we just have to essentially copy and paste these commands to get this set up. So we'll just run this directly on our Ubuntu server. So let's make that directory. We have to download tarball. So let's go ahead and grab that tarball. So this is the software that constitutes kind of our runner, which is open source and available, I think, at github.com/actions/runner, singular runner. Okay, that's downloaded. Let's extract that tarball. So this will unpack itself. And the nice thing here with the GitHub UI is it actually tells you all of the commands to run. You just have to do that copy and paste. So it's pretty simple. Even I can do it.
And Steve, we're doing this totally manually, right? But folks could prepare, VM templates, and they could be loaded up with specific tooling, for environments they really care about. So this is showing it manually, but you could automate this certainly. And yeah,
that's actually a great point, because the runners that we host, the software that we run on those, that's also open source. So you could take that repo and build your own template and automate it. Yeah, we're being a bit hands-on and manual right now. So I think this is the configuration of the runner, so that looks good. And the last step here is let's just actually go ahead and run this. So once this runner is running, it'll be available for any kind of workflows on this enterprise instance. Nothing to stop you running multiple or hosting multiple runners, maybe designed for different environments, operating systems, or kind of processor architectures. But for this demo, we'll just use a single hosted runner and make it available everywhere. So let's go back to our kind of config page here. We see that little green light, which means that our runner is running. We have some labels against it, which is a nice way to kind of categorize and target a specific runner that you need in your workflow. And just a quick check of our policies. So yeah, it's enabled for all organizations. And further down here on our kind of enterprise policies, we can see there's no policy, which means that we can actually consume any open source action on github.com that we want to in our workflows. Okay, so let's go ahead and put this runner then to some good use here in the remaining sort of 10 minutes, and we'll try and wrap this up as quickly as we can and make sure there's some time for some Q&A. So over in the Octo org here, in my settings page, there's this new actions page, and on this page, I believe we need to just make sure that that runner is available to all the repos in our org that we want to access it. So here's our kind of default enterprise runner, and you have to explicitly kind of opt in your repositories to access it. Otherwise, your workflows won't do anything. So again, I'm going to be very open and generous here and just say, you know what, all of my repos in my Octo org, I'm going to let them run whatever they want on that runner. So now, the exciting stuff, right? We've got all this configuration, all this hard work done, and we can put it to good use. So let's create a new repo, and in that we'll host a workflow. I'm going to call this spoon knife, which you might want to fork. Ta-da, boom. And I will add a new workflow file in this repo. Again, I'm just going to use the browser-based editor, which is sufficient for my needs. So your workflows need to live in a special folder in your repo that begins, is named .github /workflows. And I'll just name this initial kind of test or demo workflow just hello world.yaml, and let's code this up. I'm going to cheat a little bit, and for the sake of time, I'm just going to copy and paste this other workflow that I made earlier. It's just a little hello world, but you know, it's still worthy, I think. So let's just paste this in, this YAML.
This is good for the folks that missed the 101 also. They'll be able to grok this, I think.
Right, yeah, this should be nice and simple, I think. So it's just a hello world. So on push, we're saying on push to this repo. So any push to this repo is going to execute this workflow. We're going to run on our self-hosted runner, which is the one over there that we just stood up. And this job has actually just a single step, which is going to open an issue in our instance. So we're going to use curl and the GitHub API here. We're going to use this GitHub token, which GitHub provides automatically for us. We're going to hit this GitHub API URL, which is another environment variable that's exposed on the runner. We're going to hit the issues endpoint for our repo. And we're just going to submit this payload, which just contains a title of hello world. So yeah, I am going to go ahead and commit this. This should work fine, I'm hoping, first time. And now that it's kind of committed, it should just automatically spawn a new job on our runner. So here's our hello world workflow. This could run really fast. If we blink, we might miss it. So let's try and catch this. Here's our hello world workflow with a hello world kind of job within it. So starting up, the runner has to warm up a little bit, obviously, for us. Got to wake up there, and we can see in the log here it's running our job hello world. The open issue step is already spinning away there, and the job completed successfully, we can see. And it looks like if we navigate over to our issues tab here, if we jump over to this issues tab, we do indeed see a new issue, so that's lucky. Saying hello world and opened by our GitHub Actions bot. So yeah, that's like a very simple like hello world workflow just to prove that our runner is running. And that's maybe great as a little proof of concept, but I don't know if anyone would really want a new issue to be opened every time they pushed code. I don't know that anyone's code is truly that bad, except maybe my own, but probably not yours. So let's try and do something a little bit more realistic here with our wonderful new runner. Slightly more exciting demo and more valuable use of our resources, right, would be to build an actual application. So over here in our Octo org again, I do have an app that I've been messing around with recently. So let's go check that out. So we have this little demo app here, and it's basically just a single kind of small kind of Golang CLI that runs in a container. And it would be nice to have some CI set up around this so that I can push changes to it and be confident with every push that I haven't broken anything. So let's go ahead and hook this up to automatically build on our runner. So again, this is equivalent to the github.com experience. We're just going to jump on over to the Actions tab here. We're presented with a few recommendations. I'm going to choose the Docker kind of container CI. And we could just see that our run command is there to build our container based on the Docker file that's in the repo here. And we're using our self-hosted runner as indicated by that kind of runs on tab. I do know that because of the way Docker is set up on our runner, I do know that I need to kind of sudo this command. So let's do that. And that should run successfully. I will go ahead and commit this, give a kind of a reasonable commit message, set up CI, and let's commit this workflow. And again, in our Actions tab, here's our Docker image CI workflow firing. Again, this could go really fast, especially now our runner is warmed up. Here's our build going. It's already built the image. There's a pretty small and fast image, and probably was in the cache, all of the dependencies. So yeah, that was nice. That was fast. And now every time in this repo, every time we push new commits, our container will automatically be rebuilt on our runner, and just giving us kind of that confidence in the quality of our build and allowing us as developers to kind of move fast and ship things. We could obviously extend this workflow, right? We can lint our code, run our tests, push the container to a registry such as GitHub packages, even deploy it to an environment. Hopefully the first session today kind of gave a lot of ideas and inspiration around the things you can do with GitHub Actions kind of generally. So this is the end of our demo. I hope it gave you a little taste for how kind of easy it is to just run your software development workflows with enterprise level security in GitHub on VMware, everywhere that VMware is in your multi-cloud or private cloud or on-prem data center. Actions for GitHub.com is generally available for GitHub Enterprise Server. As I said, you can sign up for the beta at this link, resources.github.com/beta-signup. And this is scheduled to go generally available at GitHub Universe this year, which is this coming December. And there'll be tons of other exciting announcements that we can't wait to share with you all as well there. So sign up at githubuniverse.com and we'll hope to see you there. Cool, thanks everyone. So that we can hang on if there's any questions, or I don't know, Jeremy, how's it looking?
You're looking good. I think you nailed it, Steve. Didn't really get any questions in the chat. If anyone does have any, we do have another minute or so. But just to give folks a little bit more, kind of bring them back to that VMware Everywhere, as Steve said, this GitHub Enterprise Server is very, very popular with our VMware users out there. So VMware, GitHub Enterprise Server go together like chocolate and peanut butter, used very heavily. And so we're really excited to have expanded our support out to some of these hybrid platforms that we hadn't taken a close enough look at in the case of VMware Cloud and AWS, and with Azure VMware Solution being like a brand new offering there. So really excited that we could validate and do it now when we have GitHub Actions on server being in this cool beta. And so it was great to validate all that stuff together. And as expected, everything worked flawlessly, whether it's on-prem or in any of these hybrid experiences. vSphere acted just like vSphere, and it was delightful for that consistency to be there. So really appreciate the partnership with everybody, and thanks for all the folks that attended the session.
Definitely. Thanks, everyone.
Thanks a lot, Steve and Jeremy. I definitely, is GitHub Universe 2020, is that going to be free later in the year? Because that sounds like a neat one. We've been completely integrated with GitHub now. Even running this event, we put everything on GitHub. So I might want to go check that out myself. That looks pretty interesting.
Yeah, I believe it is free and it's entirely virtual. So much like this. Yeah.
Very good. Very good. Thanks. That's I learned that's new for me. So I'll do that. All right. We're like one session away from the hackathon and the end of the Crazy VMworld week. So I'm going to go get a beer from my refrigerator and pretend like I'm just going to get drunk. All right. Thanks a lot, guys. Thanks for the end. Appreciate it.
Take care, everyone.
Goodbye.